Good evening and welcome to Flat Earth, United Kingdom. Joining me this evening is Cami Knodel. How you doing, Cami?
And there's the button. I'm doing well, Nathan. Thank you. How are you today?
I'm superb. Really pleased to actually get the Hangout working. We had a few technical difficulties at the beginning with it saying that Hangouts simply weren't available at the moment and I should try again later, which was a little bit disturbing, but Bob got straight on the case and happily we're now running and rocking and rolling. So you've got your tea. Are you nice and relaxed?
I am nice and relaxed. I have my son. I have my tea. It's a chilly afternoon here. 4 degrees here and a cold 34.
Glad you're all tucked up nice and happy. So where do we begin? The subject that we I ran through a list of subjects with you, but the one I want to start with was probably the last one I went through, or second to last, which was about the article that David Weiss of Deep Inside the Rabbit Hole shared with me about a WikiLeaks expose that might be up and coming. So I mean, maybe start there. What were your thoughts when you first heard it?
It's my thoughts on it were pretty much, it's a done deal. I mean, they're going to prove that the moon landings never happened, and in my mind, they haven't happened for so many years, and so it wasn't quite so shocking. But I guess, I mean, to get out to the rest of the world, it's important. It's good. WikiLeaks is a little bit crazy. You don't know what to think about it, but overall, I think it's a good thing. I think more and more people feel the same, that it's not so shocking anymore. It's beyond conspiracy now. It's more the norm that people believe that we didn't land on the moon, and it makes no sense that we did. I mean, they talk about now how we might be able to get through the radiation belt. So are you still there?
Yeah, they did a terrible job, absolutely appalling job of the moon landings. I mean, after that article, there was a few other articles that were saying things like the Chinese found no evidence of the American landings. So you kind of sigh and go, all right, so they're still punting the same heliocentric nonsense. But the NASA moon landings 69 was just appalling. You know, it looks bad. It hasn't held up well at all, has it?
At all. It again, when they did it, and it was just grainy on TV and happening live. But in retrospect, looking back, I was quite young when it happened. It's like 5 years old, so I don't seemed real at the time.
Were you actually propped up in front of the TV then, made to watch it?
I was, and I remember, yes, we had our one TV at the time, and it was quite the big deal. I remember when Challenger had crashed, that I had gotten up early that morning. I was a big science and a space buff, and I got up early that morning before work in Denver. Took up at 6 in the morning or something, something like that. And I remember being heartbroken that day. I remember that day also being propped up, and I'd made a little breakfast spread, this and that, was all excited to watch the shuttle launch. And again, it took me days, and now I look back at it and you see how everybody's alive and well, and it's amazing. It's quite the little joke they play on us.
Well, at the time, it was very distressing because it had a teacher on board. So it really humanized the event for everyone watching it. You know, it felt like you were one step away from being there yourself. You know, your potential teacher is on that mission being blown up, but of course not being blown up. I mean, maybe you can give a bit of padding to they're all alive and well, which you dropped in there subtly.
Exactly. And yeah, you can see Sharon McAuliffe, the ninth teacher, is doing well, Krista, and yeah, it did humanize it. I was out of school at the time in my early 20s, and so I felt like I was about her age, a young school teacher, and dealing with the kids. And again, it was amazing at the time. It was heartbreaking at the time. It was upsetting, and now you feel kind of betrayed to be put through emotions like that on a woman, a joke, and a bad joke.
Yeah, just a model, basically. I mean, one of the very first, if not the first, Flat Earth video I did was about getting some sort of scale of reference with the shuttle. And there was people in a transitional shot next to it just before it took off. But you could, on my nice massive 8-foot screen, I could actually run a tape measure up it and get a, obviously very rough, but a rough scale. And you could see that it was probably about a third of the size of what they say it should be with all the equipment and fully loaded. So essentially they're just sending a firework up and blowing that up while the people on the inside and this is speculation, but they had videos of some of the parents at the launch with smiles on their faces while the thing's blowing up, which was pretty crazy. I mean, speculation, I know, but
I don't know. On this, I don't know if the parents would have known. And again, when you're if they're smiling while it blow up, I mean, I think as a parent would be it could almost be a weird smile, like, oh my God, this isn't real. This can't be happening, because it's very, very surreal. Do you think they would actually I mean, I think later on they would, but at the parents, I would think they would keep it quiet. I don't think they expected the Challenger to blow up. Maybe that was part of the game, but I don't think that they expected it to. I think they had to make alternate plans. I think it was a surprise. I could be wrong.
Oh, really? So in other words, the disaster wasn't actually a planned disaster. It's just that the firework blew up too early.
Exactly. The firework went up too early, and then how do you explain, and have living people out of that type of a blow up? And you can't. I mean, you can't have everybody's eyes, the big fireworks happening, and easily explain survivors. So I think that they were surprised by that.
Right. I mean, they made a whole massive affair of it in the aftermath. I remember watching Discovery documentaries with a really, really passionate NASA engineer talking about O-rings and the temperature being too low for the launch. It was really tugged on your heartstrings, and this is 20 years later.
Mm-hmm.
So
and that's what I mean. Watching it live, that was what I'm wondering about the parents and the different people. When you were watching it live, it took. You watch it and you see it explode, and it exploded, and you expect it to happen. When you're watching it live and it exploded, you're like, is that supposed to happen? Is that part of it? What is that? Could that have been an explosion? That doesn't look right. And then you're hoping, well, that's just, maybe a blow off of another, part of it or something. So again, during the live, there's a lot of confusion. You really don't have the clarity that you have while watching it on a documentary, or in hindsight, it's a little bit different.
Sure. I mean, again, it's one of those things that at the time may have worked to their advantage. I know they've got monuments and museums dedicated to that event. So obviously it's had its effect that's been very useful in the aftermath. I mean, do you now, with your son, do you occasionally get, reports back from school of them sitting them down in front of the ISS footage or anything like that?
He comes back with a lot of stories about like the geography and what they're saying and atmosphere and the different, he challenges everything. He comes and he does it both ways. He is not at school. I don't even know if he is a flat earther or a round earther. In other words, we expose him to everything, and he's a very, very, very bright boy, but he brings home anything from school that could be challenging and runs it by it. And they're quite fun. Pretty soon Eleanor will be doing that.
Yeah, hopefully. I mean, I don't know. I would aspire to that. I would hope that she's challenging what she's being told as opposed to just parroting it. But that will get her in trouble. But still, that makes me smile.
It is. It's more fun, but more challenging. So isn't that how it works?
Sure. Maybe we can move on a little bit to something slightly moon related. And you've talked a little bit when we spoke last time on Mechanics of the Fourth Wall about Celestine and its potential. Well, I'm not going to put words in your mouth. Maybe that's enough information for you to go from there, I think, hopefully.
No, you're on Celestine. In fact, I was wondering if it's sometime we want to do this when you threw me off on doing it, because I don't have any of the sheets up. But Celestine, again, we talked about it a little bit, and this would almost be a mini show about Celestine, or maybe Cami should do a video or something, or maybe Nathan, you could help me out. But Celestine is remarkable, the way the chemical properties of the stone, the physical properties of the stone. This particular rock will like morph on colors. It will go from white to blue within temperature ranges, within radiation ranges. It's diamagnetic. It's going to repel, be a perfect type of object if you needed something, again, in the type of model that we're looking at, to glide along and show just one face to it. So it has probably more than we could get into. I'd like to actually have all of the information up in front of me, but Celestine itself is such a fascinating, I've learned so much about it, such a fascinating stone, and has so many different qualities that are very unique for a stone. and I know I have gone over that they make some of the uses on it is they make fireworks from it with all of the colors. They make the glow in the dark paints, anything that you think of as fluorescing in just looking at it, the little glow stick necklaces and bracelets that the kids wear, things that glow in the dark. Most of this is made out of strontium titanate, which is they grind up celestine. And so these properties that you see in all of these items are a natural quality of the stone. And so again, it has the celestine, and I have not seen the celestine prophecies. Maybe that's something I should, watch his homework. I don't know where, I have no idea where it ties in. People have said, oh, Celestine, you're grabbing it because of the prophecies, but I've never seen the movie, so I'm not quite sure. Maybe I should. Have you seen it?
No, I've asked a couple of people about it, and they've said that it's very, very, very slimly related. There's a few mentions in it, but that's it. It's a fictional story, so it's not going to be that related to Celestine being the moon. That's
they're a rock, Celestine, celestite. As a rock in the moon, but it is, it's I'm holding it as a very, very good candidate, and I could see us like going on for like a half hour or so about the different properties of the stone and why it might be that, and looking at other stones or other objects that might be the moon by comparison. And so far it's still in my number one running.
Right. With it being diamagnetic, that's crucial in terms of the way we think that the world works, or the way that it seems to literally be levitating on a magnetic field. It's beyond my pay grade in this respect, because I was watching, I think his Theorohypothesis was explaining about the differences in centripetal and centrifugal magnetism, and I was keeping along with it for the most part, but even he is explaining that what it is elegant and simple, but to explain it is anything but simple. It's really, really difficult to get the actual understanding across. I'm keeping along with him for 20-30% of what he says, but while he's saying it, I'm kind of picturing, as you put it, a celestine moon, teeter-tottering, as you phrased it, on this magnetic field line that we know is in existence. We use it.
We use it, we measure with it. Again, it's part of our everyday. We know it's there. And that will bring you into other things too. This is going to bring you into that magnetic effect that when we were talking about looking at the videos, I don't know, we watched the video by Research Royal Rife. Excellent video on it. And the different, and of course, Dr. Zach not talking about the atmosphere and the refractive index. I know we want to go into refractive index a lot, but the other thing about the magnetics is the magnetics have got its own birefringence all by itself without the atmosphere and everything else. The magnetism of this model has got birefringence to it.
What's birefringence?
Birefringence would be like an easy way of looking at it is that I'm going to take a people watch some of the videos leading up to it, and the one in particular, which one did we watch to get ready for this? Was that Royal Research or
Research Royal Rife that I mirrored?
If you did if Bob has that mirrored up on Globebusters, and it's up on several things with Research Royal Rife. But on that, if you're explaining like your straw, how much light bends going from one medium to another. And so if you saw a straw bending and putting it into water and then taking a bend, your refractive index would be the amount of bend into the light on it. And so you have that. They did a wonderful, wonderful job explaining our gradient, our stacked gradient dense atmosphere, and how each level takes the light and does something different with it. Each material does, and then it compounds very much like a lens, or it can, very much like, glasses you'll see as you compound the things. So you have all of these things with the atmosphere leading into like bending the light for you. So we're talking the apparent sun, like where you would see the sun as opposed to where it would be. And then you have a whole other, so you have your atmosphere doing all the things that we're looking at, but we also need to look at the magnetics on its own, the Faraday cage effect that we live in has its own birefringence. And I'm going to, let me see if I can bring something up for you and share. It's complicated. If you think that Theoria is complicated, I have a book I've been going through a little bit. It's called Molecular Light Scattering and Optical Activity, talking about magnetically induced circular birefringence. So with what you're looking at, oops, we're gonna
just close that. It's on tab 2.
On
Not that
tab.
one. Not
Close this one. Close.
this one.
Okay.
So while you're doing that, for anybody who wants to picture what we're talking about, this is a picture fairly easy to come by. There's a stack of all sorts of different liquids going through gasoline and water and, you know, various other things, and then other solids that are in between, you know, a cherry and a cork. And this, if you were to shine light through it, or maybe a better example would be exactly what you said, a cup of water with a straw going into it. If you look at it side on, you would see that the straw was different as it goes through that layer of water. So there you go. Have you got your bit that you wanted to share, Cami?
Okay, and then that was perfect going into it. How do I share the screen on this one?
Okay, go to the little green arrow all the way to the left.
Green
All the way to the
arrow to the
left on the
left,
side.
okay.
And then select, that's not the right screen, that bottom one.
The bottom one, okay.
Yep, and say share.
Sorry, everybody, I'm not so good at this. This is just tells you how I've been like bruising or like skimming through this book along with a lot of them, but it's, Nathan, it's not easy. It's not, in other words, you want easy answers for things, but it's talking about the optical properties you're going to have in magnetic fields and how they're measuring them, the polarization of luminescence, how it affects luminescence differently than it affects, you know, the different light waves. It's complicated.
So for anybody who was hoping that they just needed to wrap their head around what Dr. Zach put out with the, is it still birefringence when you're talking about the different layers of atmosphere?
It is birefringence when you're talking about the different layers of atmosphere, and it's birefringence when you're talking about the magnetics, and it's birefringence. In other words, you're going to have, and this is what I've been like trying to wrap my head around and figure out. So when you are trying to triangulate the sun, you're trying to triangulate an apparent sun where you're visualizing the sun, not probably where it is. And hi. Okay, you put me back on and take the screen off. Thank you. I have technical assistance here. It's wonderful.
I'm the background engineer today.
So I remember even like, you know, a year and a half ago, we were working on trying to triangulate and running into a lot of troubles, and it didn't work. We watched Dr. Zach did a marvelous job trying to do it by the shadows, and my heart went for him on it. I understand the heartbreak is, you know, going through trying to do it all and not having it match up. It's a lot of work. I know I've been doing it with the maps, and you do it, but you learn so much from it. And the best part of this journey is the learning. And
yeah, I'm pretty sure it was Brian Mullen who said that one of his great teachers said you learn 10 times more from your mistakes than you do from your successes.
Exactly. Exactly. And so we're looking at, I'm trying to now step back from, you read the scientifics, and then you kind of step back and take more of a heuristic approach to it is what I'm doing right now. I've been going into scientific and heuristic phases on where I am on the map, where you just throw all the science away, you step back, look at it, follow your instinct, and go back and forth. It's a learning experience. But what you can kind of get to is we have to do a lot of work on this. A lot of work needs to be done on measuring exactly what the magnetic field is doing with the light, what the atmosphere is doing with the light, what the different things are doing with the light before you could hope to triangulate it, because we know it's not a question of if these things are happening. They are happening. It's a matter of being able to measure them. But we know that this birefringence is going on in many areas, and so you know that looking up at it, measuring the angle of it is not going to be able to give you an apparent thing on it. It takes further than that, that within it on the magnetism, if you have the different flows of it, you can have the light following it around. And I'm kind of, again, looking at the different, I don't know if you've been looking at my perspective, has been doing a lot of videos too about the light, the ambient light around you, the different lighting conditions, and how it cannot be caused by one spotlight in the way that we understand light. it comes in at different angles. It surrounds you. You have your scattered light around you. You're getting beamed with your sunlight. There's a lot of different areas to look at onto it. And I think that the magnetic model really holds the answers to all of it. I don't know if I'm smart enough to unlock them. In fact, I can almost guarantee I'm not. But I believe, like, the more I look into it, the more I see that the answers are there. And it just takes a lot of work, and it takes somebody, it's going to take some smart people working on it.
Yeah, absolutely. I mean, I'm going to take it back to basics because you've said that. So, I mean, we're talking about, you know, the magnetic fields of Earth and the birefringence and the atmospheric birefringence that it's talking about. And we're talking in terms of figuring out literally how things actually happen. Now, from a very basic standpoint, you can go out and actually just look and it just happens daily. But we take all this for granted and we're trying to figure it out. But on a very basic level, this is still a flat Earth show. And I'm going to start saying this more and more often. There's a distinct lack of curvature that we also have to just accept. Now, on many of these shows, we will just skirt that issue because it's an accepted fact for us. Whereas there may be that guy who's just watching this show who's, you know, got a live show, oh, flat Earth, that might be interesting. There's no curve. That's simple. Earth is flat. You know, that
is Earth is, you're right, no curve, Earth is flat, and it's perfect. People have to start looking at it from that angle. Isn't that wonderful, that angle a little bit? And it's an easier angle to look at than a globe.
Sure. There's two angles that we sort of come from when we look at how the sun, how the moon, how the stars, all the stuff in the sky works. And it's sort of twofold. One is kind of how we phrased it up until now, which is that we want to know how it actually works. And the other is that most of the evidence and proofs that we're, you know, given on a daily basis for living on a globe, which we do not, is sky-based. So we're in a position where we're having to debunk a lot of the nonsense that we've been indoctrinated with. So, you know, from that, we are still on a road of discovery. I mean, maybe we can move on to things like the eclipses, because they're a little bit more mysterious. I mean, how do you stand as it at the moment with things like the eclipse?
I am, let me have a sip of tea. I am in the same place I was exactly before with the eclipse. My model has not changed on that. The model has not, that I've been working on since the last time, it's not really changed that much. It's been fine tuning in, and I've been learning and going in chunks of learning and then trying to apply it to it. So the eclipse, I still believe that the sun and the moon are teeter-tottering, and in that teeter-tottering and in that seeing, I'll tell you like a couple of the different ways that I'm leaning right now. I'm just trying to decide where to go from this, where to start eclipses or that. On people that have not seen it, my model on the sun and the earth, let me share the screen again, I'm guessing. The green button.
While you do that, I'll preface it by saying, you know, throughout
the model first.
Say again, sorry?
I said definitely preface it and explain it first, because I'm jumping into it.
Sure.
Okay.
Sure. Well, we have a 13-month solar year, and throughout that solar year, we have blocks of lunar months, and they do the same thing over and over again. And we can track this. And the reason we can track this is with some very elegant information given to us by Cami, who has observed it for well over a year, probably 18 months, day after day after day after day, to figure out what it does. And that's pretty much what it takes. Shall I display your screen?
Please do.
There we go. I'll stick myself back on mute.
Okay, so if you were looking at, and I do have the cursor on it, if you're looking at this model, put the earth underneath it. Lay out the earth as a big flat. Your sun's path going around, you can make this the equator here, and then the moon's path, which is teetering up and down within the cycle. Now the sun's path, as it's going between the tropics, is going higher and lower itself, but within it's staying on a plane, and then your moon is going up and down, rotating around it.
And they're both on elliptical orbits.
And they're both on elliptical orbits. Now, the simplicity of this is that with the eclipses, what would happen is the moon's path, when it came right underneath the sun's path, would cause your eclipse in that direction. And so it's very easy that if you have your sun here and your moon is coming down here and you're here, you're going to be on a path of the eclipse. Does that make sense? Do you see the cursor or the...
I'm with you so far. All good.
All good so far. Now your other eclipse working on it is, I'm working on it that if your sun is here and your moon is here, and there are the other sides, I'm saying that I feel that there's something they're doing, tamping along this electrical field or magnetic field, that you're getting a shift in. Your moon turns red. It goes into a phase and it turns red for the eclipse. And so I believe that the magnetics and the electrical workings of this model are making a dampening field, or that we're only receiving the red light from it.
Right. And let me kind of clarify what you said really quick, Nathan. Essentially what she's saying is what a lot of people are calling Rahu for these lunar eclipses, is actually a magnetic node, okay? That's actually taking place in the field up above. I call it a node, you know, she's kind of calling it a node also, but it has been called Rahu by other cosmologies. And so that's kind of what she's talking about there. And as soon as we figure out the dynamics of the field, especially the flux lines of the field, we should be able to actually make predictions on where those nodal points will be, which should not only tell us what the eclipses are, but they should also be able to tell us when the most likely possibility of spotting a lunar wave would be. So.
Oh, right. So the lunar wave is, well, I suppose that makes perfect sense. It's another magnetic anomaly that's presumably being, is it interacting with, I don't know, I'm asking you questions you might not be able to answer now, but do you think it's interacting with the atmosphere or the moon itself?
Well, the magnetic fields themselves would be independent of the atmosphere. I mean, the atmosphere has its own refractive properties, but then when you get into the Faraday effect, that's a completely different type of refractive or birefringent property. So it's actually a combination of several things, just like on the video that we mirrored on the Globebusters channel just last week sometime. So it's very difficult to actually predict where everything is without actually knowing the lines of force. And yet that information, I believe, is out there, and we should be able to extrapolate from it at some point.
Very cool. Very cool indeed. Yeah, it always blows me away. Maybe, Cami, if you can give me your opinion on something that Stephen Chess put to myself and Bob when we last spoke, which was about there being, how can I put this concisely, a sort of like a season within a season that follows the lunar cycle. So within one lunar cycle, you would have a warming period and a cooling period. And Stephen Chess, I think he hypothesized that it, well, no, I hypothesized that it was because of exactly what you said, that during that stage of becoming higher and lower and teeter-tottering, as you put it, that you would have a climatization effect on the ground that you would notice during that 28-day cycle. I just wanted to get your thoughts on that.
I think it would make perfect sense, and it would be something worth researching and looking into it. I haven't looked into it myself, but it makes sense with the model that you would experience all kinds of mini cycles within the cycles.
Sure. As soon as he said it, I sort of thought back to, sounds really silly, but all the coats I have hanging up, and throughout a month or throughout a lunar cycle, I will vary massively what I'm wearing. You know, you go through really, really thick coats and then you go to the thin coats, but it's all in winter right now. So you kind of think, well, why am I going through different periods? Shouldn't I just get progressively thicker in the coats? You know, seems odd, but you think back on this stuff.
And we are here, I don't know if you're familiar with Colorado, which has got the claim to fame that if you don't like the weather, stick around a couple hours, because we will go from 80 degrees to snow in 6 hours. So it's hard to do the mini cycles here because we, Colorado weather is unto itself a strange again, we've had snow in July and we've had 80-degree weather in January. And so it's within the cycles, we have some really strange ones coming off of the mountains.
For sure. Now, I know there's a subject that most people who are watching at the moment are going to be really, really, really keen for you to talk about, which is about maps. So
Really?
I think so. So pretend that we've never spoken before about this subject. Start from there. Tell me what you know about maps and flat Earth.
Okay, maps and flat Earth. You can give me some different things. Okay, I'm going to want that. I'm going to want the globe. First of all, looking at the maps and the flat Earth, I've learned, again, this whole thing has been such a learning experience. I've learned so many things looking at this, including that there seems to be no accurate map of the world. And if you say it's because you can't put a globe onto a sphere onto a flat plane, then I want to know why our globes are all wrong. So it's like I've been learning a lot about the different possibilities of taking this and laying it out flat and making it work within all the different realms: sunrise, sunset, landmass, water, travel, and it's an ongoing project. Starting with this, and by the way, like here we're looking at your globe, which I don't know, on your globe's looking at it. Our land masses, we have different information everywhere on the things, and no picture, no globe, no two globes I can find are the same, no two maps. Your Gleason map, which is your flat map, puts everything beautifully in time with a few exceptions, and has got a lot of different things going for it. Your navigation and your pointing off of, which makes me feel that looking at that map, your magnetic lines are valid on the map. It's a straight, they're a straight line, not a curved line. I'm not putting this into it, so we'll just.
You want me to say it?
Please, yeah, let's have Bob say it for me.
All right. Essentially, what she's saying is the Gleason's has a lot of attributes, positive attributes that are accurate as far as being able to tell time, as being able to navigate. However, when people make the claim that there are no shortcuts on a flat Earth map, that is kind of negated by the fact is when you reorient the magnetic fields, which are going from south to north, and also other magnetic influences, you find that the straightest or the shortest distance between 2 points is never really observed, because what you're doing is you're navigating via magnetic flux lines. So that's the big difference in Cami's map and the Gleason's flat Earth map. And when you do that, you change orientations of continents to what would actually be the true directions, rather than the extrapolated ones that are brought about by calculating in magnetic declination. So that's kind of it in a nutshell.
So to wrap that up again, or to reiterate exactly what you've just said, the way that the globe has been formed is by using the magnetic lines that are used for travel daily and curving those around a ball, as opposed to laying them down flat with their curvature in place on a standard flat map representing the flat Earth, but demonstrating that we do have curved magnetic field lines, which is what you're trying to achieve. Is that correct, Cami?
That's very much what I think that was said very well.
That's actually fairly close.
Do you want to come in with me?
Yeah, I'm fine.
Come on.
So, okay. All right. Hello, everybody.
2 for the price of 1.
Bob Knodel, everybody. Hello.
Hello. All right. So, all right, where were we? It's close, what you just said. And the reason that it's not entirely accurate is because when you're dealing with navigation on a globe, you have these magnetic declination figures, okay, that pilots have to correct to, because on a globe, you're looking at north in different places, with respect to where you actually are. Now, on a flat Earth map, there is no need for declination, because north is north is north, period. And that's one of the things that once you understand that the declination is actually misleading you, because of the fact that it's trying to navigate you around a ball, which we're not on, that's one of the things that we've eliminated from our particular map. And so the other thing that Cami and I have come up with is the fact that there are definitely seemingly more than 2 magnetic influences. In other words, the standard model is a North Pole and a South Pole, but when you look at things like the South Atlantic anomaly, which is a heavily, heavily influential magnetic field, then you have to take that into consideration of how it's actually bending the field and how a compass would react to it. And so that's kind of what we've done, is we've looked at that field and we've plotted the fields around it to where it's actually changing the magnetic field of the Earth. And this is where, you know, I've come up with the concept of dead reckoning across these magnetic fields. And this is potentially, you know, one of the factors that would solve for the Antarctic, I'm sorry, not Antarctic, but the Sydney to Santiago flights, okay? That is one, and of course something that Jaron came up with Globebusters on a few weeks ago was also incredibly fascinating, and that was the winds aloft at different figures. And it appears that we are not privy to all of that information on all different flight levels, which I found incredibly interesting. Try as I might, we can't seem to find all that information. You know, they give it to you at
the 4 winds for anybody biblically inclined. Is this what you're talking about? Jet streams?
Yeah, jet streams, exactly. And obviously, there seems to be much more to them when you get into your different layers of atmosphere. Also, not only do you have different birefringent characteristics, but you also have different winds aloft characteristics. Some are eastwardly, some are westwardly. And I think that that's also part of this puzzle, is that possibly they're getting into one of those jet streams, which, you know, they can go up to extremely high velocities, you know, up to, you know, they can propel you to up to over 300 miles an hour beyond your indicated airspeed, bringing your ground speed up another 300 miles an hour. When you start looking at things like that, and also repositioning, and also taking into consideration the magnetic flux lines and dead reckoning across them, all of a sudden, when when we look at these on Cami's map, these flight times become very doable on this map, whereas it's a big problem on the Gleason's map. So, and again, you know, we may be completely wrong, but you know,
we're trained.
Yeah, but we know the Earth is flat. We know it is, and we're operating from that premise. Therefore, anything that appears to go against it has to have another explanation. Just like, you know, the southern stars. You know, we're operating now on the premise that stars, of course, are not stars. They're not thousands of light years away. They're not suns. They are some sort of sonoluminescent manifestation that is occurring locally in our atmosphere. And, you know, when you start looking at it that way, suddenly all of these little debunks that the ball earthers are firing at us start falling away. And I think that we're well on our way to really bringing some good evidence to that. And I guess I might as well mention this now, Nathan, what we talked about earlier. I want to tell everybody that I have been working on doing a debunk of a video, okay? And this video is by an airline transport pilot in Australia. I believe he lives in Australia. He is also ATP rated. And by the way, the ATP is absolutely the top of the line pilot's license that you can get. It's what all the airline transport pilots must have to be able to do their job. So this guy's got a dual ATP, both in America and in Australia. He goes by the YouTube screen name Wolfie6020, all right? So Wolfie6020 did a video, and by the way, he's a flat earth debunker, but he did a video basically addressing the idea of whether or not pilots have to compensate for the curvature. And surprisingly, his answer was yes. However, what he did was he very much downplayed the angles and the degrees that you are required to make. His observations of 8 degrees every hour, or no, I'm sorry, 4 degrees an hour. Anyway, I've got it written down, are correct. So basically everything that he's talking about in the video is correct, except the way that it's being expressed is very, very, very misleading. So what I did is I did the math behind it, because I know better. I mean, I know that we're not compensating for anything. And he's basically trying to say that, yes, pilots do it, but it's so gradual that you'll never, ever notice it. And in a lot of ways, he's accurate on that. However, he's misleading and giving the impression that these are just occasional adjustments rather than something that needs to be continuously maintained. So what I did is, this goes back to Jaron's whole inverse pi thing of the 0.318. And then, of course, I looked at it as 636, whatever. So I did the math.
You've got to stop there because you've got to explain a little bit what that means, because there will be people watching that don't know what you're talking about. We're talking about measuring Earth's curvature in different ways, so that we're not necessarily just obeying the 8 inches per mile squared rule, because it's fraught with problems when you go beyond certain distances. So therefore, there's other ways of measuring it. And actually, you put this really well before we started, Bob, when you said about when you're traveling over a sphere, it's never going to be this exponential measurement. This 8 inches per mile squared really is a bit fallacious. Am I right?
Yeah, exactly. And that's one of the things that I had a problem with. So what I did, all right, after I did the math, and I'm sitting there just shaking my head going, wow, this is going to go over like a lead balloon when we start revealing his figures. So I said, okay, I'm going to assume I'm wrong. So what I did is I went online and I hired a double master's degree recipient in both mathematics and engineering from an Ivy League university, right? And this guy's an Indian guy.
What does that mean? What's an Ivy League university?
Ivy League means Harvard, Yale, Princeton, those type. Oxford, type of just top of the top, cream of the crop. Because obviously there's a lot of these people who are running around, with these big degrees and working at McDonald's or whatever. So lo and behold, they're not hard to find online, right? And so it cost me a bit of money, and so I went ahead and I hired this guy and I showed him my figures and my conundrum, and basically I said, I need the correct math for this, and you show me where I'm wrong and show me the correct math. Well, he was able to work on it for well over a day, and he came back and he talked to me today, just this morning, about this, and he's like, your math is correct. I can't even explain it. In fact, this is so insane to me that I can't even charge you for this, right? So I'm sitting here with a credit, right, of being able to use an Ivy League graduate master's level mathematics and engineering student, or not student, but graduate. And he simply was dumbfounded when we looked at the math behind this curvature, right? And that's something I'm going to reveal on Sunday, but I have to tell you, it is a globe killer. It is a globe killer, dead, say goodnight, it's over. And what I'm going to do is I'm going to expose exactly how this was done, and I'm going to basically make the offer that if anybody can come up with math that thinks they can debunk this, I still have that credit with this, with this institution that has access to all these Ivy League graduates.
So there may be a challenge being put out then. That's
exactly right. And I'll say, if you think you got it, I may even sweeten the deal by throwing $100 of my own money in as a prize. But the bottom line is anybody that thinks they have the math that's going to debunk what I'm going to present on Sunday is welcome to try and do it. And I will be more than happy to use that credit to run it by our Ivy League expert. But he is so dumbfounded by what he discovered that he may very well be a flat earther by tomorrow.
I said this before without giving too much away, but that guy's breakfast is going to be the best breakfast he ever tasted.
Yes, indeed. So that's what's coming on Sunday for Globebusters, and I have just been absolutely giddy today because, I mean, I knew my math was right, but I had to humble myself and say, look, this isn't my bailiwick. I'm an engineer, but math is not, something that I do every day. So I said, let's put an end to this. Let's hire a pro. Let's bring in a ringer. And I did. And the results are rather stunning.
Definitely look out for that on Globebusters. It will, again, without giving too much away, the adverse is true. It will be the ultimate in flat earth proofs as well, and not just mathematical. I really wish I could go into more detail, but of course, look out for that on Globebusters this coming Sunday. So cool. Right. Excellent stuff. I'm going to touch on a topic now, a bit of a change, which you guys maybe don't talk about quite so much, but it's crucial in physical terms and in spiritual terms, if you want to look at it in that way, and you'll know what I'm talking about, which is about not just geocentricity, but in terms of things like redshift. And anybody who's watched The Principle will know that essentially we are at the center of everything.
Yes.
That's a pretty big deal. I don't know, Cami, maybe if you can go first, tell us when you discovered that literally we are not flying through space, traveling and hurtling and whirling and spinning, but stationary and very much at the center of it all. How did that make you feel?
Completely overwhelmed. It brings, I mean, it comes to you in small pieces, and it's very, very surreal. And at some point it really clicks into all of the pieces. And I think I even, I mean, you adopt a song for it, that you listen to it, you do different things just in the mood. It's a very spiritual, it's a very overwhelming, it's experience. It's a relief. It's because a lot of the times, I think I can speak for a lot of us, when learning different things about the solar system and when learning different things, the physics and things going on, we believed by the nonsense that they gave us, because we couldn't make sense out of it, that we were too stupid to understand it. That was really the conclusion you'd have to come to, is we'll just let the people that could do the equations and that figure it all out, because I obviously am not bright enough to get this. And yet around in other areas of life, you seem very bright, you know, people, you don't seem that stupid. So a lot of it was a weight, that a lot of things that didn't make sense and that you learned how not to trust yourself, they started making sense in you. So a lot of it is the power that you have inside yourself, that you've been deceived and that you really are bright. You are special. Each one of us is bright and special, and we can look around and figure it out. We're not too dumb. We don't need dark matter. We don't need them to invent all of these things to make nonsense out of our world, when our world is so beautiful.
Yeah, it's one of the most exciting things, is to be able to say, I don't know. I don't know why the sky is blue.
Right, exactly. And it's beautiful. And it's like, I don't know, they don't know either. And it's a question, and it's a beautiful question. And how the world works is so much more beautiful looking at it in this perspective than a weird ball flying through space, randomly going. It's every day is a miracle.
That's true, but at the same time, there's the flip side of that coin, which is every day we are presented with the same nonsense, the same lies, the same control structures that get us looking up at the sky, getting us thinking about externalizations of our own abilities, all of these things that tie our fellow man into basically being insignificant. And yet it's a really pleasurable experience to know that, we do actually have a very significant place. Where I am sat now is very much significant. It's not left for dust 30 seconds later, 5.5 million thousand miles away, in the expanding nothing. Being at the center of it all is a very crucial detail that most people can't handle. If you try and explain it to them, they don't understand. And, their concepts of where they are so much more complicated. And it brings me to my point, when you actually think about that, it leaves you with a lot of anger towards the people who've literally lied to us about where we live and what we are. So when we go to the extent of doing what we're doing now, having hangouts, talking about it openly and freely, we find that we face ridicule, that it's not NASA and the liars and deceitful people of this world that receive the anger that they are so sorely due. It's us that receive the ridicule. And isn't that just so bonkers? How do we change or flip that back the way it should be, where people can recognize that we're not spinning, moving, we are stationary. At the very least, wrapping their head around being at the center of it all, they may not get it immediately, but certainly it's obvious and observable that we don't spin, we're not moving. So just to get people to that point without screaming retard in our faces, how do we go about that, do you think?
Well, they're going to scream retard in our face, so we should harden ourselves to that a little bit and think back to a couple of years ago what it would be like if we were hearing for the first time, and how silly and removed you feel from it until you, again, the more you look into it, the more you learn, the more you know you don't know, and the more fascinating it is to learn. The negativity, everybody deals with it in their own way. I found, like, even with Globebusters is all about busting the globe. Who's lying, who's telling the stories, who's doing, and it's depressing. Day in, day out of you being lied to. And so, I mean, I found my little niche on, like, trying to find the fascination and find the truth in it in the puzzle. Everybody is going to have their own place and their own niche in it, and they're going to have to deal with it their own way. Like you said, when you did it, how did it feel? I did. I mean, I cried. It brought tears to my eyes when it really became real that, this is the world, the realm you're on. Your creator is amazing, and you've been lied to by these people. And again, I deal for it by trying to solve a problem instead of focusing on the lies and deception. We have so many people doing that, and that's so depressing to focus on. So I know you were talking about red shift and blue shift earlier, and I know that you were talking about Theoria earlier. Have you seen his explanation on red shift and blue shift magnetically? Because he does have it figured out.
No, I've not seen that.
Really?
Who is it?
Theoria. I have it up in one of the, right here. Let's see if I can do this. I'm going to drop something into the chat that maybe you can drop into the chat for people.
It's an amazing guy. I'll put a link to one of his random videos just so that people can subscribe to him, because this guy, he's into photography. He's talking about lenses, but at the same time he's explaining how the world works. He's amazing.
He is. There are brilliant people everywhere. He doctors act with different people putting things together. I have every bit of faith that we can, maybe not to the micro level, but we can figure out the world with all the minds working on it. I'm in awe every day of the people, and that's kind of what I feel that I do is I just discover these brilliant people and read through and observe their ideas and where they come from on it. But people in their minds, again, that's part of the miracle. I'm going to, here, we'll bring him up a little bit. Share. Oops. Here.
This is a Ferrocell video, right?
Spectrum.
This is, yeah, with his Ferrocell, which I have a Ferrocell now. I don't know if you know, I got my magnets in a Ferrocell.
Hitherto, this has been explained.
This is not set up for audio.
Oh, it's not set up for audio, and we'll take it down.
I can hear it though.
Mother Nature.
You can drop it in. I put this one in here. He's going to explain how red shift and blue shift work and their magnetic properties.
Inertia and magnetism.
Oops.
That's, I don't.
There we go. Okay. I did. I was trying to do it and then stop sharing.
Okay.
I'll pop a link in the chat now, and I will also put a link in the video description for this video once it's gone to archive. So yeah, check out Theora Hypothesis. Make sure you subscribe. Definitely watch his back catalogue. Well worth it.
Well worth it. You watch it, then you rewatch it, and then you watch it one more time again. And then if you're really lucky, you have Bob watch it next to you, where you hit pause and say, what does that mean? And what does that mean? And we spend a lot of time watching this, but again, it's a fascinating. I would have never thought I would learn so much about magnetics, about electronics, about electricity, about, again, things that would have never, if you told me I'd be doing this a few years ago, I would have laughed in your face and said.
That's it. That's what it's all about. As I said earlier, for those people who are still on their spinning ball thinking that, meh, You know, people live, people die. There's nothing much to life. There could be 1,000,001 other worlds with 1,000,001 other species on 1,000,001 other planets and 1,000,001 other galaxies, and so it goes on. Wrong. This is it. We're it. You know, there may be more that way.
Right.
As for that way, don't really know how much we're going to figure out and how quickly we're going to figure it out. We've been lied to a lot, and it seems to me like we are being directed to look in those directions. You know, that's the way we're being told to look, so that we don't go that way.
That way, exactly. Look out, like hundreds and thousands of light years away, which again makes no sense. Again, it all boggles the mind. And then when you stop and think about it and how beautiful it is, the redshift and how they're measuring things, I always thought that was one of those that even like 6 years ago, I had told my coworkers that this is going to be something that comes out, that redshift, blue shift, and the way they're measuring it is wrong, because it's always felt absurd. And we'd make little jokes like that. Again, we did the science pages and that at work, but redshift and blue shift going down theory did such a beautiful job explaining what they really, really are. And then the ferrocell, I was going to tell you, I did get a ferrocell. And I have magnets, and I have them playing. I'm working out for the map different magnetic patterns, the ways that things can flow, and how compasses work over the different layouts of it. I'm going slowly at this end, but having a blast working on the map and just adjusting things. Like I held it up in front of you where we are with the lines. What I've been doing recently is I've taken it off of the computer. You saw with all the plotting in the cities. I've taken, again, I'm on more of a heuristic approach right now where I'm just doing it instinctively. You're familiar with like the magnetic pattern. And I'm working with right now, like niggling it in some more continent sizes and how they would, it actually, I do this over light boxes. And so you're not going to see it well here, but I do it with the light back, with the graphs and then underneath it.
Can you hold it up once more and just keep it static just for maybe a second or two, just so it focuses?
Sure.
Back a bit, back a bit.
A little bit back. Oops.
Up, down, in between. Back.
Yeah.
Perfect.
Okay, and these are hand drawn that I work with them through a light box underneath it, and I do the time zones and the different things on layers. And I found it's easier just working with them. Like you do layers on a computer, I'm layering them over a light box and picking up lines and tracing paper on that. Slowly, 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 you move one thing for one, you move something in time and to correct for it in time, and then you've messed it up in distance, and you've messed it up in a lot of different ways. And so it's a lot of erasing and a lot of moving around. I'm not quite ready to release yet, but I get closer every day.
What do you do, Cami, on a day-to-day basis?
On a day-to-day basis, right now, and I should be looking for a job right now on the thing. Anybody has ever? I'm a housewife right now. I take care of my husband and my kids. I make meals, clean the house, work on world puzzles, and
tell what you used to do.
And run errands. And that what I used to do was I was a operations manager in a jewelry store for 25 years.
And a
gemologist.
A gemologist?
Yes.
And
so actually, I used the refractive index, and we joked on it. I have my own refractometer. I don't know if you know that, but it's a little bit different. I'm not doing the atmosphere, but I actually have a refractometer, a polariscope, and all of the fun little equipment. So I had to laugh on that, but it's looking at it a whole different way, looking through the atmosphere on that.
We will come to that, but the reason I asked what you do on a day-to-day basis was because let's pick housewife. That's fair enough. Currently, you are mapping the world. That's what you're doing. So for anybody else who's out there who goes, you know, I'm currently unemployed, looking for work, housewife, doesn't matter what you are, an ex anything. You, like Cami, could be mapping the world for yourself. That's amazing.
And I think everybody should be. I really do. I think you get enough people doing it and put the pieces together. But I do need to go back to work. This is all encompassing. I mean, it really has become quite a passion. You can't look at the world the same way ever again. You can't go back.
I mean, you touched on, I'm glad you did the segue instead of me. So you touched on you being a gemologist, which brings us into refractive indexes and things like that. So how has that been useful in recent times?
Well, it's useful mostly because I understand what it is somewhat more than most people that aren't used to the term. But I have to say, even in gemology, refractive index would be a test that you would test a gemstone for, that you would put it on a piece of equipment, put a little drop of methylene iodine or, a little solution on there, drop it on, and you would take readings from it and go to your chart and say 1.79 or 1.76 this, 1 point this, oh, sapphire, or, it helps you identify gems. But what it does as far as in this world is it helps knowing about rocks when looking at the world and how they come about, and that has been helpful in putting this together. And then knowing the terms polarity, refractive index, all the things that they're bringing in with atmosphere and what we're doing. I think it's a little bit helpful being familiar with the terms, that they're not new at all to me. They're just being applied completely different. And I'm having to think about what they are more. I can't tell you how many times I've checked polarity on something and it never occurred to me what, in other words, when I was taking the refractive index and taking the polarity on a specimen, I'm just writing it down and figuring out what it is. I'm not really thinking about what I'm doing. And I think a lot of us do this in our day-to-day jobs, is you do what you're taught to do and you get to the results, but you don't stop and say, what does this mean, and what does the polarity mean in it, or how did it get to be like this, what impact does it have,
and the most important question, why and then again, hitting all of the different, it takes you on to wanderings into different areas. I know I was laughing, the Marianas Trench, we were watching a earthquake special about the induction and subduction rates and zones, and how that they spent years and years trying to figure out if the crust was pushing in here, if it was growing, where was it going? And they came up with this folding over because the magnetics were changed in layers. I don't know if you've looked at that by the Marianas Trench, that by there's zones of land, positive, negative in strips. And this is what they're basing that we had our pole ships on. Is they're saying this amount of time it shifted, this amount of time happened and it shifted. And yet I look at the patterns that are being produced under the seabed and I see the same patterns that I'm supposed to see about the alternating magnetics to levitate things above us. And it's like, I don't think this is a pole shift. I think it was designed this way. And I think it's part of our plan. There's so many little pieces that are part of the working model. Just the way you describe it, it just sounds like Earth's one big giant toroidal transformer.
It's a circuit.
It's a circuit. It's a circuit. A beautiful circuit, a growing circuit, a magical type of circuit. So,
right. I think I was hoping to keep this to about an hour, but we've run over a little bit.
Okay, well,
but I'm going to ask the most important question of all of them, which is, in light of all of the lies and the deceit and the general deception that we're perpetrated on daily, do I tell my kid about Santa?
That's the all-important question. Bob, do you have a...
I'm sorry, what was the question?
The question is with all of the deception, with everything going on in this world and the lies we've been fed, does he tell Eleanor about Santa Claus? No, this is serious. Bob thinks it's funny. I see this.
I don't think it's funny. This is a very serious topic. This has caused a lot of arguments.
You know what, Nathan? I mean, that's something I haven't given a lot of thought to. I understand the objection to it, absolutely, because I understand what Santa Claus really stands for. But then again, it's also part of childhood. So I'm just going to not answer that.
There's an abstain from Bob. What do you say, Cami?
This is wrong, but I like the magic of Christmas. I mean, I like the childhood. I would say that, you know, maybe past a certain age, and like we were talking earlier, the Bonanza Jelly Bean reference, that's for people who have not read the book, Even Cowgirls Get the Blues. It's like your reality being stripped from you, what you've been told, everything being stripped away. I don't think Santa Claus is everything. It's not the same as saying the earth is a globe and you're flying through space. I mean, your Santa...
You have a beautiful analogy with Even Cowgirls Get the Blues.
Even Cowgirls Get the Blues, you have the analogy with that. Tom Robbins is friends of Terence McKenna, by the way, is a very strange author. He wrote a book, Even Cowgirls Get the Blues, and part of the book was about a character, Bonanza Jelly Bean. And her main thing is that, you know, she grew up and was lied to about everything. And one of the things that happened is every Christmas Santa would bring her a little cowgirl outfit. And she would dress up, and she was going to be a cowgirl when she grew up, and she built her whole life around this. And then she got to a certain age, and they're like, sweetheart, Santa, not only is Santa not real, but you don't get to be a cowgirl when you grow up. We're just kidding. That's not real. That's just all make believe, pretending the whole bit, and it's not something that you can really do. And she was like, well, you know, Tooth Fairy never had credibility. Santa Claus is sad. But now you're taking away a cowgirl, and that's my reality. That's what I really wanted to, you know, Santa is one thing that he doesn't come through, but you're changing my reality on me. And she didn't care for that. She didn't like the way she was lied to. And in the book, she wound up basically taking over a feminine hygiene ranch and kicking out all the people and taking over so she could be a cowgirl. So she did get her way in the book.
They twisted her reality so much that she changed the world around her.
Changed the world around her, so she made her reality to be yes.
Right. On that note, I'm going to end it there. So I'm going to say a massive, massive thank you to Cami Bob for being on Flat Earth UK. Thank you very much, Cami.
Oh, Nathan, thank you so much for having me. Maybe we can do it again sometime.
And also a massive thank you to Bob Knodel. If you can hear us, Bob, do you want to just pop into frame just to say goodbye?
Absolutely, I hear you, and thanks for the interview, and we'll be talking to everybody on Sunday on Globebusters.
Superb. And to all of you who have joined us in chat, thank you very, very much for being here. I've been Nathan Oakley. I'll see you all in the next video.